So we've been working on mathematical induction, and I want to show you the process that you need to follow in order to solve a problem. So we're given here a series that is all of our even numbers, okay? So where n is some even number for a positive integer n that you can give me. This statement here says that if we were to add all of these numbers up to some even number, that we know, we just need to take whatever even number that is, whatever order that is on the even numbers, which would be n, our term, and then we would just take the next term, multiply them together, and we will get our answer. We will get our sum, excuse me. So what we need to do for mathematical induction is two things. We need to first off show that P1 is holds true. So basically that means that the formula that's listed over here works for the first term. So our first term here is 2. Okay? So if we look at that, our first term, then n is going to be 1. So we're going to do 1 times 1 plus 1, which is the same as 2. So this holds true. So our first step passes our test. Excuse me. So we need to look now at our second step, which is a little more complicated. Our second step says that we need to show that for some positive integer k, that this formula, if we assume that to be true, that it also therefore implies that it works for the next term. So what we need to do with this is we need to retranslate our equation up here into terms of k. So what we are going to do here is we are going to say p k equals 2 plus, and I'm going to skip a few steps here. I'm just going to turn this into a 2k, and then that equals k times k plus 1. So all I'm doing there is replacing my n's in this step with k's. And then I'm just classifying this as p sub k. So what I need to do now is I need to create a p sub k plus 1. Now p sub k plus 1 has p sub k in it. It is involved. So I'm going to go ahead and rewrite the first part of p sub k, which leads up to 2k, and then I'm going to add my k plus 1 term. Now in order to do that, I have to input k plus 1 into the formula for my terms. Now I'm getting that formula right here. So it says 2 times whatever term I want gives me my value. So I need to do 2 times k plus 1, because now I'm using k plus 1 as my final value. Okay? So those should match up. So this is a step where a lot of people have problems. They don't see what to do. And so I want to show you the best method. Okay? The best method, best way to look at this is that I have 3 things here that are all equivalent to each other. Okay? These are all equivalent. I know that these two are equivalent because they're exactly the same thing. I know that these are equivalent because of my equal sign there. That is a true statement. We are assuming this line here to be true. We're assuming this line. So if I can make that assumption, to make things easier on myself, I'm going to replace my this section right here, my 2 all the way to 2k, with my k times k plus 1. It'll make things a lot easier on me because I'll just have a simpler, more manageable expression to deal with. So if I just go ahead and replace this, I'll have k times k plus 1 right there, and then I'm going to drop down this part here. I'm not messing with that at all yet. So this is this is equal to p sub k plus 1. So this is an expression that is true thus far, and my goal is I need to try to make this expression look like a form of this. Okay? I need to make it look like that. Okay, so I want to simplify. So if I go ahead and simplify this, I will get k squared plus k and then I will get plus 2k plus 2. And if I further simplify that, all I have to do is combine my k and 2k. I'll be left with k squared plus 3k plus 2. So right now I have a quadratic expression that I need to make look more like this, because I'm trying to show that this k plus 1 series works with this formula here. Okay, so the step that I want to take here is I want to factor. Okay, this up here is factored, so I want my expression down here to be factored in a similar way as possible. Okay, so I'm going to flip to the next page and go ahead and factor this for you. So you get k squared plus 3k plus 2. So if I want to factor this, let's set up my binomials. I know that because this just has a single, a number 1 as a coefficient, I can go ahead and do k's right there. So now I need to figure out two numbers that will multiply to make positive 2 that add to make 3. So two numbers that multiply to make positive 2 that add to make 3 would be positive 2 and positive 1. Well, now what I have is very interesting. What I have here is my new equation, or my new expression, excuse me, is k plus 1 times k plus 2. My original is n times n plus 1. Well, as you can see, this number is just 1 larger than that, if we're assuming n and k are the same. So, and that's okay to assume. So this is one term larger than something else. And then we have k plus 2, and we have k plus 1. So both of these are just one number away from each other. That's really the key here, is that these two are consecutive terms, and these two are consecutive terms. So because I decided to use k plus 1 on to solve, to show that this works for everything, these two expressions are the same, and this becomes even more apparent if you look at it like this. So I can look at this as k plus 1 times k plus 1 plus 1. And as you can see, I just have a term times a term that's 1 larger than it. So in this sense, now that I've gotten to this point, this is proof that my original statement is correct. So once you get to this point, you would say that by mathematical induction, I have proven the original statement to be true. This is a simpler example than some that you will see, but it'll at least show you the process that you need to make. Again, you want to start with our first criteria. It says that it must hold true for the first value in our series, and that did happen. Then what we need to do is we need to translate our our equation on top. Most people use k values. We need to translate that. Then we need to take our sum, especially with the new translation, which is right here. We need to take that sum and replace our original series with that. So then we get to a line like this. Once we do that, we need to simplify, and we end up with something simple, and then we need to factor that, or we need to adjust that to where it fits with our original model. Okay?